In this video for section 9.1, we're going to introduce the idea of a hypothesis test. As we've already discussed, because of sampling error, the mean of a sample will probably not be exactly equal to the population mean. So for example, if we have a machine that is supposed to fill orange juice bottles with 32 ounces of orange juice, and we take a sample of 10 bottles and find a sample mean of 31.9 ounces, we might wonder if this is close enough to 32 that we can say that yes, the mean of the population is 32 ounces. What if the mean of the sample was 31.5 ounces? Or what if it was 31 ounces? What is close enough to 32? So that's the question that we're going to answer here. We already saw one method for answering this question, which was to calculate a confidence interval. Then you would look to see if the confidence interval contains your value for the population mean that you think it is. Another method is called conducting a hypothesis test. So when we're doing a hypothesis test, we have two hypotheses, the null and the alternative. The null hypothesis, which we write H sub 0, contains an equality sign. So it could be equal to, greater than or equal to, or less than or equal to. The alternative hypothesis contains an inequality sign, not equal to, greater than, or less than. And based on the data, we are going to either reject the null hypothesis or not reject the null hypothesis. So if we reject the null hypothesis, this means that we have enough evidence to support the alternative hypothesis. We can't say that the alternative hypothesis is true, or we can't prove that it is true. All we can do is say that we have evidence to support it. If we do not reject the null hypothesis, then we do not have enough evidence to support it. So you can think of this sort of like the court system. The two things that we can say is we say that either someone is guilty if there's enough evidence to support the idea that they're guilty, or they're not guilty if there's not enough evidence to support the idea that they're guilty. We don't ever say that someone is innocent because we can't prove someone is innocent. All we can do is say if the evidence is enough that they're guilty or not enough, then they're not guilty. So in the orange juice example above, these would be my hypotheses. My null hypothesis is that the population mean is equal to 32 ounces. My alternative hypothesis is that the mean is not equal to 32 ounces. I'm not sure whether it would be greater than or less than 32 in this situation. Sometimes you will have a direction, but in this case I don't. All I'm saying is that it's not equal to 32 ounces. So let's look at example 9.1. The registrar at a university claims that the undergraduate students work, on average, more than 20 hours a week. Write the null and alternative hypotheses. So what I'm looking at here is the claim is that the students work more than 20 hours a week, on average. So we're talking about a population mean. I usually think it's easier to start with the alternative hypothesis and then write the null hypothesis based on that. So my alternative hypothesis is that the mean is greater than 20. And we always use greater than, less than, or not equal to symbols for the alternative hypothesis. We do not use the line underneath. So the mean would be greater than 20. My null hypothesis is always the opposite of that. So once I have my alternative, then I write the opposite statement for my null hypothesis. So if the mean is not greater than 20, that means it's less than or equal to 20. So that would be my null hypothesis. Let's look at example 9.2. A machine is set to fill cracker boxes with 20 ounces of crackers. Technicians want to determine if the machine is working properly. Write the null and alternative hypotheses. So in this case, my alternative hypothesis is that the machine is not working correctly. Or in other words, the mean is not equal to 20 ounces. And so then my alternative hypothesis, my null hypothesis, if this is my alternative hypothesis, is that the mean is equal to 20. The opposite of not equal to 20 would be that it is equal to 20. So this would be my null hypothesis. This is sometimes called the idea of a status quo. So your null hypothesis is basically that there's no change or there's no problem. Whatever you say is the population mean is in fact the population mean. So it's possible that our sample data could lead us to make a wrong decision if our sample happens to contain individuals that are far from the true population mean. So there's two types of possible errors, type 1 and type 2. And this chart shows there's 4 possibilities here. If I don't reject my null hypothesis and the null hypothesis is true, then I have made the correct decision. If I reject the null hypothesis and the null hypothesis is false, then I have made the correct decision. If my null hypothesis was in fact true, but I concluded that it was false, then I made a type 1 error. And if I concluded that the null hypothesis was true, but it was in fact false, then I have made a type 2 error. And this image here shows kind of a nice way to think about it. If the null hypothesis is not pregnant and the alternative hypothesis is pregnant. A type 1 error would be telling someone that they're pregnant when they are in fact not pregnant. So this would be rejecting the null hypothesis when the null hypothesis is true. A type 2 error would be saying that someone is not pregnant when they are in fact pregnant. And so in this case, the null hypothesis should be rejected, but it is not rejected.